Saxon's Trig, lesson 88, is about exponential functions, specifically growth and decay. Now the lesson chooses to go ahead and begin with a formula. So it's the amount that you have after time has gone by, so a sub t, comes from a sub the original amount, multiplying with e, as in natural logs, e, and then a constant, and why they use k again for constant, I don't know, it's just a math thing. Constant times time. So this is the basic formula that will work for something growing. Scientifically, you hear the terms the bacteria grew exponentially or the radioactive material decayed exponentially. That's what this is, the growth and decay formula. Then they choose to show you that the graph of these is really basic and simple. So whatever your original amount is, a sub o, if it's growing, you're just going to do a curve, because anything with exponential with the e is going to graph a curve, and it could be kind of wider out or super tight. Or if it is decaying, it's going to be going downward, or it could, take a little more time to go downward. Actually, that looks like it's growing. Sorry, let's make that a little more downward and get rid of that one. So again, the graph is super basic, where all you're doing is labeling your number here and then drawing that curve. And I should point out that this is your time line and this is your amount line. All right. Ignoring their darkened words there. Jumping to example 1. The number of bacteria present at noon is 400. So my a sub o is 400. 9 hours later, time, 9 hours, the bacteria numbered 800. So after time, it's 900. Make sure I didn't skip anything. 400, 9, 800. Wait a second. I wrote 900. Should have been 800. That's why we double check ourselves. Okay. Assume exponential growth and find the number of bacteria present at noon the next day. So they want the amount after time has gone by, going from noon to noon. So they want after 12 hours. The original amount is 400. I have my E. I don't know my constant, but I do know that my time is going to match that same 12. So I need to stop and use this information to find the constant to plug into the ultimate equation we're trying to solve for. So just a second, this should have a time. Number of bacteria present at noon was 400. 9 hours later, I usually do this one first and then fill in this one. I think that's part of what is messing with me. This is trying to say 9 hours later. The time was 9 hours. So 9 hours later is the 800. Yeah, okay, perfect. Now we can do this. So 800 equals the 400E constant, and the time was 9 hours. Haha, there we go. So we're going to first divide by the 400 to get the E alone, because that's where the constant is that we're trying to solve. 800 divided by 400 is 2, E to the 9K. I'm just going to rearrange the order because we like coefficients in front of variables. And then how do I remove the E? Oh, I remember this from another lesson. I natural log both sides, because when I natural log here, I kill the E. So the natural log of 2 is going to provide us with a decimal on our calculator, and that should be 0.693 equals 9K. Then divide by the 9, so we know that the constant is 0.077. And then we fill our constant in here at 0.077. So now on the calculator, 0.077 times 12. And this time I'm not natural logging, I'm telling it e to that power. So your e to the x button, or however yours has it in there. And that should give you 400 multiplying with 1. No. Oh, they didn't tell me that number specific. Well, how sad. Okay, whatever that number is, e to that power is then going to multiply with the 400. That they did tell me. So A after 12 hours is 2,539 bacteria. Word problem should have an answer label with it. That's how many bacteria after 12 hours. All right. Oh, did the original ask for a sketch, or did they just choose to do it? Number of bacteria present. Nope, just said find the number of bacteria present at noon the next day. And noon to noon was 12 hours. Wait a second. 12 hours or 24 hours? Oh, goodness gracious. Problem there. Hold that thought. This shouldn't have been a 12, and that's why I didn't have the numbers. That should have been after 24 hours, 12 to 12. Sorry, it was a day later. Yeah, in a classroom, somebody would have yelled at me and told me that should have been 24. So 0.077 times 24, e to that power times 400. Now you should get the 2,539. They chose to do this sketch. However, it did not ask for the sketch, but 400 is the original. It's growing, so some sort of curve upward would have been the quick graph. Example 2 now. The number of bacteria present when the experiment began was 1,200. So A sub O is 1,200. After 100 hours, so the time is 100 hours. I think that's why I wrote the A sub T, because I just written the 9 hours. After 100 hours, there were 2,700 bacteria present. So A after 100 hours is 2,700. Assume exponential growth and find the time required for the number of bacteria to increase to 300,000. This one does say to sketch. So it wants us ultimately to get, I think I just said 300,000, 30,000, coming from A sub O, which was 1,200 E. I don't know the constant. I'm going to have to stop and find it. And ultimately, it wants to know the time. So that's where we're solving. So using my original amount of information, after 100 hours, so 2,700 came from 1,200 E to the constant, and the time was 100 here. So 2,700 divided by 1,200 gives me 2.25 equals E to the 100K. Natural log both sides. That'll cancel off the E. Turning this into 0.81093 equals 100K. Divide by 100, that just slides that decimal over. So now it's 0.08193 for my constant. Just a second. What? Oh, good grief. I moved it one place. I was writing by 100. That's moving it 2 places. I knew that didn't feel right. That's better. 0.008, yes, is my constant. That can be filled in up here, 0.008. And I wouldn't fill in the whole thing. I'd probably only do the one if it were me. And then on the calculator, 30,000 divided by 1,200. Then natural log that to kill off the E, and then divide by the 0.0081. Your time should be coming out 396.92 hours. That's the answer that they asked for, but it also said to do a rough sketch. So my original amount was 1,200. Growth means I'm making that curve climb, and that's really all. I mean, they label the time, they label the other. I just kind of keep that sketch super basic. Example 3. The amount of substance initially present is 400 grams. A sub O, 400 grams. And after 90 hours, so the time was 90 hours, so A sub 90 is going to give us 380 grams remain. So this is obviously a decay because it's dropping. Assume an exponential decrease and determine the half-life. Now there's a new term you've not heard before. So I can ultimately find my constant from here, and what they're wanting me to solve for is a half-life. Now the half-life means I'm going to fill in a half. That is overriding the amount after time divided by the original amount. It's saying those two are automatically going to the half. So since I've used those up, what that's leaving me with is my constant and my time constant, which I can find from this information over here. So half-life will automatically always go to an answer of equaling a half, overriding the a sub o, or a sub time dividing by a sub o. Okay, double checking the question. Determine the half-life of the substance. Make a sketch of the graph. Oh, okay. When it says determine the half-life, that's, I've told you that you're filling in a half here for this particular piece, and I can solve for how long it will take me to get to the half-life. But when it wants to know how many grams the half-life is, it's half of your original amount. So 200 grams is part of the answer that they're looking for there. And they were trying to technically use that to fill in and then stop and find the half, but I've already given you that shortcut piece there. So over here, you're going to have 380 equals the original 400e to the constant and the 90 hours. So again, 380 divided by 400. Natural log that to kill the e, divide by 90. You should be getting a constant of negative, now that's because it's decay, 0.00057. And once I have that, I plug it in up here, negative 0.00057. And then I take the natural log of 0.5, which kills off the e, and that decimal divides by the negative 0.00057, and my time should come out to be 1,215.79 hours is the time that it takes to get from 400 down to 200 grams. Decay tends to be much smaller than growth does because that's the way it is in the natural scientific world. So you would expect to find the same thing in the math problems here. Example 4 and the final one. A radioactive substance decays exponentially. After 100 years, 500 grams are left. After 200 years, 300 grams are left. Oh, I guess I should put G with those. Find the amount of the substance that was initially present and its half-life. So we need to find these in their formula formats to begin to substitute or eliminate depending on what we discover that we can use. So 500 came from a sub o, which we don't know, e, to the constant, and the time was 100. This one came from, oops, hold that thought. All right, so we were filling in here, so 300 equals a sub o, which we don't know, e. We still don't know the constant, but we do know that that's 300. Now, what I can do is actually, because I can't substitute or eliminate, that causes too many problems. But what I can do is set them as fractions. So 500 over 300 equals, we'll just have one equal sign, this over this. And then I can do the 300 divided by 500 and get 0.6. And I can cancel off the a sub o's and just keep my e to the, and then what happens when you are dividing fractional things? You actually subtract them. So, oh, good grief. I think I pulled the 300 from here. That should have been 200. Yikes. Is that right? Yes, my time was 200. Yes, 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 yes. 200 minus 100 should give me 100 with the constant. Okay, I think we're on track here. So you are not going to instinctively know that you're supposed to divide these, but once you see it, you'll know to do it in the future. So this divided by this gives me the 0.6. 200 minus the 100 gives me the 100. The other thing I was sitting here thinking about was the fact that if I move this up, I get a negative. But in order to avoid negatives, let's flip-flop those and say that we did 300 divided by 500 to get the 0.6. The a sub o's still cancel. 200 minus 100 gives me 100. That way I'm avoiding all the negatives. Natural log both sides to kill off the e. So you'll get a decimal over here equals 100k, and then divide by the 100 so that your constant comes out negative 0.005. And then that can be plugged into either one of the originals. I'm trying to match the one the book did. So fill into 500 equals a sub o, which we don't know, e to the negative 0.005, and the time in that one was 100, so times 100, and then calculator, 100 times this, e to that power, 500 divided by that number tells me my a sub o, and that should be coming out 824.36 grams. And the other thing it asked for was the half-life, so you basically want to divide that in half. I was like, that their next darkened number is definitely not half of 800 something. Did it say time? No, it says find the initial amount and its half-life. All they're wanting is half of this at 400 something for the half-life. 402.18, I think, or something very close to that for the half-life. It doesn't ask for the sketch, and for some reason they decided to find the time it took to get the half-life, but I don't think that's what they're asking in the original. And it's half-life. I think they thought that when they worded half-life, they were asking for half-life in time, but you can go back and plug those numbers in and get the time, but we're not going to.